Hi, my name is Yosafat Kenny Andrew. You can call me Yosa, and I'm a student at Atmajaya University, Yogyakarta. Today I'm going to talk about robot and artificial intelligence and what kind of robot do I want to have. First thing first, what is robotic? Robotics is the intersection of science, engineering, and technology that produce machines called robots that substitute for or replicate human actions. And what is a robot? A robot is the product of the robotic field, where programmable machines are built that can assist humans or mimic humans' actions. Robots were originally built to handle monotonous tasks like building cars on an assembly line, but have since expanded well beyond their initial uses to perform tasks like fighting fires, cleaning homes, and assisting with incredibly intricate surgeries. Each robot has a differing level of autonomy, ranging from human-controlled bots that carry out tasks that a human has full control over, to fully autonomous bots that perform tasks without any external influences. As technology progresses, so too does the scope of what is considered robotics. In 2005, 90% of all robots could be found assembling cars in automotive factories. These robots consist mainly of mechanical arms tasked with welding and screwing on certain parts of a car. Today, we are seeing an evolved and expanded definition of robotics that includes the development, creation, and use of bots that explore Earth's harshest conditions, robots that assist law enforcement, and even robots that assist in almost every phase of healthcare. While the overall world of robotics is expanding, a robot has some consistent characteristics. 1. Robot all consist of some sort of mechanical construction. The mechanical aspect of a robot help it complete tasks in the environment for which it's designed. For example, the Mars 2020 rover's wheels are individually motorized and made of titanium tubing that help it firmly grip the harsh terrain of the red planet. Number 2. Robots need electrical components that control and power the machinery. Essentially, an electric current is needed to power a large majority of robots. Robots contain at least some level of computer programming without a set of code telling it what to do. A robot will just be another piece of simple machinery. Inserting a program into a robot gives it the ability to know when and how to carry out the task. So generally, there are 5 types of robots. Number 1 is pre-programmed robots. Pre-programmed robots operate in a controlled environment where they do simple, monotonous tasks. An example of a pre-programmed robot will be a mechanical arm on an automotive assembly line. The arm serves one function: to weld a door on to insert a certain part into the engine, and its job is to perform that task longer, faster, and more efficiently than human. Number 2 is humanoid robots. Humanoid robots are robots that look like or mimic human behavior. These robots usually perform human-like activities like running, jumping, and carrying objects, and are sometimes designed to look like us, even having human faces and expressions. Two of the most prominent examples of humanoid robots are Sophia and Boston Dynamics Atlas. Number 3 is autonomous robots. Autonomous robots operate independently of human operators. These robots are usually designed to carry out tasks in open environments that do not require human supervision. They are quite unique because they use sensors to perceive the world around them and then employ decision-making structure to take the optimal next step based on their data and mission. An example of an autonomous robot will be the Roomba vacuum cleaner, which uses a sensor to roam freely throughout a home. Example of autonomous robots are cleaning robots, lawn trimming bots, hospitality bots, autonomous drones, and medical assistant bots. Number four is teleoperated robots. Teleoperated robots are semi-autonomous bots that use a wireless network to enable human control from a safe distance. These robots usually work in extreme geographical conditions, weather circumstances. Examples of teleoperated robots are the human-controlled submarines used to fix underwater pipe leaks during the BP oil spill, or drone used to detect landmines on a battlefield. Number five is augmenting robots. Augmenting robots either enhance current human capabilities or replace the capabilities a human may have lost. The field of robotics for human augmentation is a field where science fiction could become reality very soon. With bots that have the ability to redefine the definition of human by making humans faster and stronger. Some examples of current augmenting robots are robotic prosthetic limbs or exoskeletons used to lift heavy weights. So, after we know about robot, what is artificial intelligence? Artificial intelligence, or AI, is a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. AI is an interdisciplinary science with multiple approaches, but advancements in machine learning and deep learning are creating a paradigm shift in virtually every sector of the tech industry. Artificial intelligence generally have two categories. Number one is narrow AI, sometimes referred as weak AI. This kind of artificial intelligence operates within a limited context and is a simulation of human intelligence. Narrow AI is often focused on performing single tasks extremely well, and while these machines may seem intelligent, they are operating under far more constraints and limitations than even the most basic human intelligence. Narrow AI is all around us and is easily the most successful realization of artificial intelligence to date. With its focus on performing specific tasks, narrow AI has experienced numerous breakthroughs in the last decades that have had significant societal benefits and have contributed to the economic vitality of the nation. A few examples of narrow AI include Google Search, image recognition software, personal assistants, and self-driving cars. Much of narrow AI is powered by breakthrough in machine learning and deep learning. Understanding the difference between artificial intelligence, machine learning, and deep learning can be confusing. Machine learning feeds a computer data and uses statistical techniques to help it learn how to progressively better at a task without having been specifically programmed for that task, eliminating the need for millions of lines of written code. Machine learning consists of both supervised learning and unsupervised learning. And deep learning is a type of machine learning that runs inputs through a biologically inspired neural network architecture. The neural network contains a number of hidden layers through which the data is processed, allowing the machine to go deep in its learning, making connection and weighting input for the best results. So number two is artificial general intelligence, or we can call it AGI. AGI, sometimes referred as strong AI, is the kind of artificial intelligence we see in the movies. AGI is a machine with general intelligence and much like a human being. It can apply that intelligence to solve any problem. The creation of a machine with human-level intelligence can be applied to any task is the holy grail of many AI researchers, but the quest for AGI has been fraught with difficulty. The search for a universal algorithm for learning and acting in any environment isn't new, but time hasn't eased the difficulty of essentially creating a machine with a full set of cognitive abilities. So, after all of the explanation, what kind of robot do I want? Personally, I didn't like human robots. I think it's creepy and I'm not comfortable being around it. So the robots that I want is autonomous robot. Specifically, I want a robot that can clean my house, that do not require human supervision. So my house will always be clean because I'm a lazy person when it comes to cleaning my room and house. So it will very helpful to have a robot that do the job for me. So the robot that I want doesn't have much knowledge because I don't like advanced robot that have their own mind and something like that. I think it's creepy. That's why I don't like the humanoid robot. So the example for my robots is Roomba cleaner. Roomba is a compact, computerized vacuum cleaner that automatically guides itself around your home like a conventional cleaner. It picks up dirt with spinning brushes and a vacuum. There is a side-mounted flailing brush that pushes dirt underneath the machine, and once there are two or more counter-rotating brushes pick up the dirt and direct it toward the powerful vacuum, which sucks it away into a little storage bin, unlike a normal cleaner. Roomba moves itself around your room with two large tractor-style wheels, each one independently driven by a separate electric motor. The wheels can turn in opposite direction, which means Roomba can literally spin on a dime and cleans almost any space it can drive into. Powers come from an onboard rechargeable battery pack. Virtually all of Roomba's features have been designed to use as little power as possible, so it can work a quite long time, around 90 minutes between charges. Roomba has numerous onboard sensors to detect dirt, dodge obstacles, and steer clear of things like tassels on rocks and telephone cords that could cause it problems. When it's finished, it snips back into docking station and recharges itself for next time. So that's for my presentation. Thank you and goodbye.